guys, now that we're going to go on, we're going to apply the 3 theorems that we've learned. The first theorem that we learned was working with angle-angle similarity, then we had side-side-side similarity, and then we had our side-angle-side similarity. So we want to explain why these triangles are similar and then write their similarity statement. Where the cool thing is we look to see the hints that the diagrams give us. Notice here they said nothing about sides, so right away, which one should you be thinking about? You should be thinking angle-angle similarity. And so I need a second pair of angles because I know my right angles are going to be congruent. So what would I need? A second pair. Well, I hope you see that second pair in the vertical angles. So now that I have 2 pairs of congruent angles, then I know the triangles are similar. So why are those triangles similar? AA, similarity. Then we have to write the similarity statement. So we go triangle ABC is similar, and now remember we have to matchy. And I know a whole bunch of you just rolled your eyes for that. Stop. Okay. So I got ABC here. I have to go from the right angle to not marked to marked. So right angle to not marked to marked. So I go D, E, C. So that one's angle-angle similarity. Now the next one, it looks like we have side-side-side similarity, but we have to make sure all the sides are proportional. So it's very easy if I go from the small triangle to the big triangle. I go segment PR to SU. We know that's going to be 2 to 3. And I use their bases, but then I notice that they have pairs of congruent legs on these isosceles triangles. So I really only have to do it once. So I'm going to go PQ is to ST, which is the same thing as going to RQ is to UT. But with that I get a 3 to 4.5. And I want this to be 2/3, so I don't want the decimal to be there. So I change it. I multiply both the numerator and denominator by 10, and I get 30/45. So we get rid of our decimal, right? So what's 30/45 reduced down to? 2/3. So 3/4.5 reduces down to 2/3. Well, I have my pairs of corresponding sides. They're all the same. They have the same similarity ratio. Notice I didn't mention any angles. So that's using my side-side-side similarity. And so I have my triangle PQR is similar to triangle. And I went PQR. So I can go triangle STU, or you could even said maybe triangle UTS, and you would have been just fine. So if that's what you wanted to do, either one of those would be fine. But that's using the side-side-side similarity. Then on the next one, if you notice, they don't mention the third sides. I can't find the third sides. So this one means probably side angle side, but you need that pair of congruent angles right there. Vertical angles come in handy again. Now here's where people mess up a lot of times. They forget to correspond. That means the smallest sides need to correspond with each other. The middle sides need to correspond. So remember, 12 and 16 need to go together, and 15 and 20 are the ones that need together. Not 15, 16, not 12 and 20. They have to matchy-matchy in the sense the smallest side goes with the smallest side. So 12 to 16, what does that reduce down to? 4 comes out of both. That's 3/4. So looks like my similar ratio is 3 to 4, but let's check to make sure the other one works. So 15 to 20, do I still get 3 to 4? Yes, so that means my sides are proportional. So by side angle side similarity, the triangles are similar, and I'd go triangle TUX is going to be similar to triangle. If I go TUX, I'm going to have to go VXW. Oops, I should actually be that. I said VXW, so I said TUX should be VWX. Make sure I say it the right way, or I'm not matchy, as we all know. Sorry, it's 10:15 at night, and so I'm a little loopy. So apologies, guys. You think I'm weird in the morning. You should see me at night. Okay. And I know there was a whole bunch of groans for that one too, so sorry. Okay, now the next one, we want to explain why the 2 triangles are going to be similar. So they talk about ABE and ACD. And I want to redraw this so you can see these a little bit here. So here I have ABE, and then I got the larger one right there, and I get ACD, and those are right angles. Now this one is 9, this is 5. Now AC ends up being 12, and this is x. Now it would be really nice if I could do side angle side, but the problem is I don't know this side, so I can't say they're similar by side angle side. So I have to have something else. Well, I don't know the third pair side, so it's not side, side, side. It's not side angle side. The only thing that could work would be angle, angle. Well, it's angle A. Angle A is congruent to itself. Angle A is reflexive, is congruent. Let's put it this way. Let's do some good old properties here. Angle A is congruent to angle A. Why? Reflexive property. All right. And we also know that angle B is congruent to angle C. And I got to make sure I name that correctly. Angle ABE is congruent to angle C because all right angles are congruent. So we know the triangles are similar. So triangle ABE is similar to triangle ACD by AA similarity. Now I love angle angle similarity because it's like the easiest one to do. So now that means my corresponding sides need to match up. Well, here's a cool thing. I will always give you 2 of the sides that work. So I know this one's going to be 9:12, not 9:3. Remember, it's whole side to whole side. So small triangle to big triangle, 9:12, as small triangle to big triangle, 5:x. Now I can go ahead and simplify this. That's going to be 3/4. Cross multiply. I'm going to move that over here. I get 3x is equal to 20. Divide by 3. X is 20 over 3. So what's the length of segment CD? The length of segment CD is 20 over 3. All right. Now let's use this type of stuff to help us. They say find the value of x. Now here's the one thing you can assume. Triangles are similar, okay? So if they're similar, we should be able to do these. But it might help for some of you to redraw them. Now, hopefully you can see small triangle and a big triangle. And the corresponding sides have to match up, okay? So if I'm doing this one, I have my smaller triangle. I'm going to go 12. You can see that there. 17 and 15. I'm going to do the bigger triangle now. 12 plus 8 is 20. This one over here is 25, and I get x, okay? So I want them to be corresponding, so they're similar to each other. Well, the cool thing is I know they're similar by, are you with me? Okay, by side angle side because of this reflexive property up here. So then we do matchy-matchy. We set up our proportion, and I'm going to go small to big triangle. Small triangle is to big triangle. So I know 12 is to 20 as small triangle is to big triangle. I'm just doing my corresponding parts. So 12 is to 20 as 17 is to x. Go ahead and reduce. You get 3/5 equals 17 is to x. Cross multiply. 3x equals 5 times 17. All right, let me move that up a little bit. 3x is equal to, oh, I do believe that's 85. Divide by 3. X is equal to 85 over 3. And that's okay. Now let's do the same type of thing here. Now again, these two triangles end up being congruent by, okay, you guys ready? Angle, angle. Because I have a pair of congruent corresponding angles because of my parallel lines being cut by transversal, and my angle up top that's congruent to itself. So if I look at those two triangles similarly again, this one's 3 and 4. And then I got this bigger triangle here. This is 8. This is 4 plus x. We should now be able to mark how they correspond. Now, do I have a pair of corresponding sides that do match up? Yes, the 3 and the 8. So whole side to whole side. So I'm going to go small to big again. 3 is to 8, as the small side, 4, is to 4 plus x. So I cross multiply, I get 3 times the quantity, 4 plus x, equals 8 times 4. Distribute, 12 plus 3x is equal to 32. Subtract 12, 3x is equal to 20. Divide by 3. X is 20 over 3. Are you guys starting to see kind of how those work just a little bit more, I hope? Now, let's try another one. Matching these up carefully. here we have a pair of congruent angles because they're vertical angles, and then we need to make sure we match the corresponding sides carefully together. Okay, remember the two larger sides go together, the two smaller sides go together, and the sides that are opposite the same angles go together. So we need to match them. Now, you decide, big to small, small to big. I'm going to go small to big. And I'm going to do it like this. And there's a couple different ones that would work, okay? Some of you might go smaller one to smaller one. So 8 is to 10 as 11 is to x. So small is to big, the small is to big, okay? And you get that, you get 4/5 equals 11 is to x. You cross multiply. You get 4x is equal to 55. X is going to be 55 over 4. Now, what if I want to do it a little bit differently? What if I wanted to go to the 12 and the 15 together? Or what if I want to go big to small? Well, I could have gone 15 is to 12 as x is to 11. So I just corresponded with them, my corresponding sides. Look what happens here. This becomes 5 is to 4 as x is to 11. And look when I cross multiply. Do I still get exactly the same thing? Isn't that cool? It works either way. Okay, so now for time-wise, I'm not going to do a new page here, but let's just go ahead and go to the last problem here. This is actually a physics types problem where you're using the reflections and angles of reflections with mirrors, and it's actually called indirect measurement. So this is just indirect measurement. It's how to measure things without actually taking a measure tape when you're working with it. Here this girl Natasha places a mirror 24 feet from the base of an oak tree. She walks backwards until she can see the top of the tree, okay, in the middle of the mirror. So she puts it right there. At the point that Natasha's eyes are 5.5 feet above the ground, her feet are 4 feet from the base of the mirror. Now notice what we do is the angle of reflection and the angle of incidence, I think is what it's called, is the same. So I know I'm trying to form these similar triangles together, is what we're doing. And we're going to assume, of course, she's perpendicular to the ground and the tree is perpendicular to the ground. So they're similar by angle similarity. So now set up a proportion. I'm going to go small to big. 4 is to 24 as 5.5 is to x. Well, then I'm going to go ahead and cross multiply with these. Okay? So first, I reduce. 5.5 is to x. So then I can go 1 times x is x, and 6 times 5.5. Well, x is going to end up being 33. Now what's that going to be labeled in? 33 feet. Very good. So the tree is 33 feet tall. And that's just a quick, easy example of indirect measurement using similarity.